this a shot. Integer arithmetic. We're going to execute this code here and see how it looks. All right, so A is 10 and B is 20, and I print them out. Then I just add and subtract and print them out. So this is pretty simple. Now when you launch it, it's going to spend a few seconds spinning up a container for you. Now it has RAM and disk. There you go. A is 10, B is 20, added and subtracted. You get the expected numbers, 30 and minus 10, and they're all integers because I didn't put any decimal points in any of them. So I can do multiplying and dividing. And I think I'll just replace this code with that code rather than putting it in a separate block. So A multiplied is 200, dividing is 0.5, A over B, and that's now a floating point value. Division always gives you a floating point. Even if you did B over A, which is 20 over 10, and could be done as an integer, it's still going to be a floating point answer. Wait, oh, it's still running, okay. There, dividing is 2, but it's 2.0, a floating point value. All right, and then you can do exponentiation and logs. So I'm going to have math, and now I can do math log of A, log to the base 2, and then I can do A to the B to exponentiation is A to the B, all right. That's going to be 2 to the 4. And then I can take logs of A and B, and I can take, it looks like I can do the same thing twice. Let me run this. Yeah, log of A. Oh, here I just prepared log of A. Okay, is math log A to the base 2. And then I printed them out here. I did it in 2 steps. I could have just put this whole expression in the print, but I put it in a variable and then printed it here. So this log of A to the base 2 is 1. 2 to the 1 is 2. And log of base B, B to the base 2 is 2, because 2 to the 2 is 4. All right. And again, notice the log produces a floating point output, just like division does. All right, and here's binary and hexadecimal. All right. So A is 7 and B is 24. And if you convert it to binary, 7 is 111 because it's 1 plus 2 plus 4. And 24 is 1, 2, 4, 8 plus 16. And here's hexadecimal, which is base 8. And if you're not familiar with binary and hex and base 8, there's binary games you can play, and I'll demonstrate one of them a little later tonight to get you started on that. If you haven't learned your binary and hexadecimal yet, you ought to learn it, because it's important to understand what's going on here, because if we're going to be working with the raw bits and binary versions pretty soon, well, in 142, not this class, but in 142 you'll be using it a lot. So you might want to learn it. But if you want to put it off till a later class, you could. So here I've got 0x for a hexadecimal number and 0b for a binary number. So this is F0, which is 15 times 16. This is a binary number, 11011. So that's 1 plus 2, no 4, 8 and 16. That's 24 and 3. That's 27, I think. So I think I'll find here 15 times 16 is 240 and 27, I think. Yeah, okay, 240 and 27. And then you can print them, the strings, FF, and you can convert FF to decimal, 8 to the base 16, and that's going to be 255. And D is 11101, so that's 1 but no 2, 4, 8, and 16. That's 29, I think. Yeah. So anyway, you can practice moving things around in various bases here. And that shows you the story, and there's just a few flags to figure out here for doing that kind of mathematics. Quite a few of them, so it's good, clean fun. All right, so let me stop this one.